In this section, we will be viewing graphical presentations with a critical eye. This article refers to a study of advertisements for drugs on the news and warns consumers to be wary when watching such advertisements. In an earlier study, a significant percentage of graphs associated with drug advertisements in medical journals were also found to distort facts. What factors can make a graph misleading? The examples presented in this section will help us answer this question. Example 1. The following two graphs show federal defense spending in billions of dollars for the given years. If we look carefully at the years represented and the spending reported, we see that the two graphs represent exactly the same data, yet they don't look the same. Which graph would we use for each of the situations described below? Situation 1. We want others to believe that defense spending remained nearly stable over this time period. Situation 2. We want others to believe that defense spending showed a dramatic increase over this time period. Notice, because the function value beginning the first graph is 0, the bars on the first graph are longer than the bars on the second graph. This makes all of the bars look pretty similar in height, which might lead people to believe that spending remained nearly stable over this period. On the other hand, the fact that the y-axis starts with $400 billion means that the part of the bars that represent 0 to 400 billion are missing on the second graph. The result is that the bars appear to have a wide range of heights. In fact, the bar that represents the year 2011 is about 6 times as tall as the bar that represents the year 2004. Thus, if we want others to believe that defense spending remained nearly stable over this time period, we might use the first graph. If we want others to believe that defense spending showed a dramatic increase over this time period, we might use the second graph. Example 2. The following two graphs show what the wealthiest Americans in the top marginal income tax brackets would pay if the tax cuts enacted during the George W. Bush administration were allowed to expire. Which graph better emphasizes the possible change in tax rates? Both graphs show that if the tax cuts were allowed to expire, the top marginal income tax bracket would go from a rate of 35% to a rate of 39.6%. This is in fact a 13% increase. However, this first graph shows a second bar that is 6 times the height of the first bar. This makes the percent increase appear to be 500%. Let's compare this to the second graph. Notice the second bar on the second graph is not even twice the height of the first bar. The fact that the y-axis begins at 0 gives us a graph in which the heights of the bars appear to be very similar. The result is that this graph de-emphasizes the possible change in tax rates. Therefore, the graph on the left, although less honest, better emphasizes the possible change in tax rates. Note, in this graph, the percentage change appears to be around 500%, while in the second graph, the percentage increase appears to be what it actually is, around 13%. In the previous examples, the strategies used for emphasizing change included 1. Make the range of the vertical axis scale smaller. In our example above, the graph on the left had a vertical axis range of 34 to 42, or 8 percentage points, while the graph on the right, the one that de-emphasized the change, had a range on its vertical axis of 0 to 45, or 45 percentage points. making the range of the vertical axis scale smaller might mean making the space between the tick marks represent a smaller quantity. Notice, on the graph to the left, the space between each tick mark represents 2 percentage points, while on the graph to the right, the space between each tick mark represents 5 percentage points. Also notice that 2 percentage points on the graph to the left take up the same amount of space as 10 percentage points on the graph to the right. Another strategy we used to emphasize change was to make the vertical axis begin at a number greater than 0. Once again, the graph on the left, which better emphasized the change in tax rates, had a vertical axis beginning at a number greater than 0. Here it was 34%. While the graph that de-emphasized the change had a vertical axis beginning at 0. The strategies used in the previous problems for de-emphasizing change were simply the opposite of the strategies used to emphasize change. For example, instead of making the range of the vertical axis scale smaller, we might make the range of the vertical axis scale larger. And instead of making the vertical axis begin at a number greater than 0, if we want to de-emphasize change, we will make the vertical axis begin right at 0. In summary, if we want to emphasize change, we will view the data using a narrow lens. That is, we will create a y-axis scale that begins shortly below our lowest data point and ends abruptly after our highest data point. On the other hand, to de-emphasize change, we will view the data using a broad lens. We will use a y-axis scale that begins long before our lowest data point and ends a while after our highest data point. Example 3. The following table shows the average price of a gallon of regular gasoline in January of the given year. Proposition. The average price of a gallon of regular gasoline showed a significant increase from 2007 through 2013. Make a bar graph of the data that you would use for an argument in support of the proposition. Then, make a second bar graph that you would use for an argument against the proposition. In order to argue in support of the proposition, our bar graph must make it appear as if the change in gas prices during this period was significant. To do that, the bars must show a great variation in heights. In this example graph, this was accomplished by creating a y-axis scale that begins shortly below our lowest data point, $1.83, and ends abruptly after our highest data point, $3.30. Notice the scale in this example goes from $1.80 to $3.40. On the other hand, to argue against the proposition, our bar graph must make it appear as if the change in gas prices during this period was insignificant. To do that, the bars must show very little variation. In this example, this was done by creating a y-axis scale that begins at $0 per gallon, well below the lowest data point, and ends at $8 per gallon, much, much higher than the highest data point. Note that if we wanted to make the changes seem even more insignificant, we can end the y-axis scale at $20 per gallon, or even $40 per gallon. If we did that, any changes in price would be so minute that they would be unrecognizable on the graph.